Okay, fine. Then you read from here, range of audible and ultrasound. Write the heading and
Okay, sir.
read it.
Uh,
Yeah. Have you written?
range and range of audible sound and ultrasound. The human ear responds to to sounds with frequencies in the range from 20 Hz to 20,000 Hz. This is called the audible range of human ear. Example of vibrating sources that produces sound is the audible range of frequencies are drums, guitar, strings, tuning fork, human vocal cords, and diaphragms of loudspeakers. Inaudible sound waves, those whose frequencies are less than 20 Hz, are in infrasonic range. Source of infrasonic waves include earthquakes, volcanoes, and waves produced by vibrating heavy machinery. The hearing range of elephants and whales extend into the infrasonic region. Frequencies above 20,000 Hz are in the ultrasonic range. The
Okay.
audible range of dogs.
Okay. Thank you. So you see what you have to write. You write range of audible sound, human, range of human audible sound. Huh? You write it, huh? Are you writing?
Yes, sir.
This way, right? Range of range of human audible sound. Huh? 20 hertz to 20,000 hertz. Okay.
Sir, done.
Then you write this part. Ultrasound is the sound with frequencies higher than 20,000 hertz. This part you write also. Okay.
Okay, sir.
So we are done with this part. Now we are going to next. Uses of ultrasound. Uses of ultrasound. So we have here five uses of ultrasound. You just read it and I will tell you how much you have to write. You don't write to everything. Just we have to write the key points from here. So we have here 5 points. That means we are having five uses of ultrasound. So first two uses, Monica, you read first two uses.
Ultrasound is used to clean street lights by immersing the light unit in a tank of water and using ultrasonic waves to dislodge the dust particles from the surface of the unit. It is also used to clean jewelry and intricate mechanical and electronic components and weld plastics. Other application of ultrasound is in quality control of metals and meat. Ultrasound is used to detect the position of flaws in metal and in determining the thickness of lean and fat meat in livestock while animals are still alive.
Okay, wait. Then we have here two uses. Now you write this heading uses of ultrasound. Then write how much I'm saying you. You write here ultrasound is used to clean. Ultrasound is used to clean. Uh, is to clean street lights. Then jewelry. Then and intricate electronic components. Okay, this much you write, huh? What I gave underline, that much you write. Then you write other application of ultrasound is in quality control of meats and metals and meat. So Mahi, are you writing? Hello, Mahi.
Yes, sir.
Yeah, please do it. At least if you write, you can remember all this.
Done, sir.
Yeah, Mahi, are you done?
No, sir. Sir, done.
Okay, very good. Now you read. Mahi, continue reading. Next,
Okay, sir.
next three you read.
Ultrasound is used to form images of babies in the womb. Prenatal scanning, figure 16.6. High frequency ultrasound, typically 3.5 million hertz, is sent into the body and partially reflected as it encounters different types of tissues. This reflection are used to form an image on a television monitor. Ultrasound is also used to provide images of the heart, liver, kidneys, gallbladder, eye, and major blood vessels. In hospital, ultrasonic power is used to pulverize kidney stones, thus avoiding the need for surgical removal. Automatic focusing cameras are ultrasonic echolocation to determine the distance being photographed.
Okay, so we have here three more uses. The first one, that is out of these three, first one, and in order, third one, ultrasound is used to form images, right? Okay,
Yes, sir.
and these images are formed images. Ultrasound is used to form images uh, on a television monitor. Okay, you write
Okay,
this.
sir.
You write this part, that I'll tell you what to write. First, you write this sentence. Ultrasound is used to form images uh, on a television monitor. Okay.
Sir, done.
There you write uh, what I am underlining. High frequency ultrasound is sent to the body and is partially reflected as it encounters different types of tissue. Okay, so done.
Yes, sir.
So what does it mean? Pulverize means anything. Do you know what is pulverize?
No, sir.
Yeah, Monica, you know? You have the diction.
Pulverize means to remove the stone kidneys or something, like break them.
Yeah, break them into small parts, right? Small pieces so that they can go through the urine, right? Other than
Yes, sir.
operating, we can crush them into small pieces, right? By giving ultrasound. Okay,
Okay, sir.
is it clear?
Yes, sir.
So,
Sir,
hmm, yes,
does cloning exist?
cloning exists, but it's not a very effective or useful thing so far for the mammals.
So why did they stop cloning?
The problem is for humans, it's creating it might create some problems. Like if they are making clone of you, then uh, that will be exactly like you. So your clone will be in identity crisis. Your parents will take you or your another clone, that one. Which one will give priority? This is one thing. Another thing is when you will have family, that will be another problem, right? So it's a moral issue. Like you are one of you are the managing director of one of the company, right? So your clone, what will be his position? Okay, this way, like Bangladesh's Prime Minister Sheikh Hasina. So if we make clone of her, then who will be the Prime Minister actually? Do you understand?
Oh,
So
yes, sir.
in this way is it will make lots of problems, lots of issues. That's why in the human cloning is in internationally it is not encouraged or it is discouraged. Is it clear?
Yes, sir.
This is one thing. Another thing is like the one which one is coming from cloning. That one is not that much, what should we say? Like your your immunity, uh, your your strength of the body, the way it has. The cloning one does not have that one. Is it clear? So they don't survive for what information I got so far. Like they produced one, sheep, right? From the clone. Can you remember? So
I
yeah,
I remember the one when they cloned a sheep,
yeah,
like, yeah,
yeah. So that sheep,
lamp.
yeah. So that one actually did not last for a long time. That one died. Okay, and different kinds of diseases. It was affected, and what I said, the immunity problem. Quickly they can be, affected by any disease, and they cannot be cured so well. That's why, uh, for all these issues, it's been, almost discouraged and stopped. Okay. So
Okay.
what is the use of cloning to make a copy, right? Like that copy
Yes,
you
sir.
can get in other ways. Lots of ways are there. Like if you think of plants, then you can have lots of plants, the similar plants from the seeds or by grafting, right? Isn't it? And
Yes, sir.
if you think of animals, also you can reproduce lots of animals by other means. So cloning is a very sophisticated, so it requires lots of time, lots of care, and lots of what should I say? It's very cost costly, right? Expensive. So
Yes.
why
Yes,
we'll
sir.
go for that? It's like just one invention. Uh, we got it. We understood we can have clone, but it's not that much necessary for us. Okay,
Okay.
for our life. So we don't need to continue it. That's why we don't see it anymore. Okay,
Okay.
now
Okay,
it's
sir.
clear to you.
Yes, sir. Sir, I also heard that cloning is haram because
Yeah,
only our God
already
can
I
play.
already told you that one, right? About morality. From moral background,
Oh
if
yes.
you think it's not actually fair to do cloning of humans, right?
Yes, sir.
So this one now, like if you think of that, uh, like one senior person, he's made clone, right? Then his children, who will they call dad, or who will they call mom, right? This is actually
Yeah.
problem, right? Huge problems. I'm just saying about your one. Then there are lots of issues, right?
Yes, sir.
Okay, now the last one, read. You see, automatic focusing cameras use ultrasonic echolocation to determine the distance being photographed. So this one is like you are giving one sound, ultrasound, then that sound can be detected by the echo coming here, coming back, that can be detected by camera, right? Because sound signal we can convert to electrical signal or electromagnetic signal. That one can be again converted to sound signal. Okay, so that is it's like there are some devices we can convert sound energy to electrical energy, right? Like microphone, isn't it? Hello.
Yes, sir.
So this way we can also, like this one image we are having. This is also like one sort of example that we can get image from the sound, right? Sound reflecting back, then we are getting the image. So here also we are having echolocation. Yeah, like you are sending one sound, that sound is returning back to you. You know the when the sound is produced and when the sound is returning back. The time you know that you know speed of sound in air or speed of sound in water, speed of sound in other medium. If you know, then you can find the other values, right? Isn't it?
Yes, sir.
So you can find the distance from there where the object is. Is it clear? Like simply if we think of the position of the stone, like where the stone is in your kidney or where the stone is in your some gallbladder, right? So uh, if you want to get the position, we are using also ultrasound, right? That how many centimeters deep it is from your skin. The doctors can find it, right?
Yes,
Hello.
sir.
So this way also we can use ultrasound or ultrasonic signal for getting the location of anything. Okay, is it clear? So the fourth point, you write ultrasound is used to crush kidney stones. Okay, to crush kidney stones, uh, thus avoiding the surgery. Okay, avoiding the surgery. Just you write here, avoiding the surgery. Is it clear? Hello, have you written?
Yes, sir.
Yes, sir.
Yeah, right. This way you write like small. You don't need to write everything. You write ultrasound is used to crush the kidney stones, thus avoiding surgery. That's it. Then we have uh, automatic focusing cameras. Ultrasound use automatic focusing camera to get echolocation. Hmm. To get echolocation. That's it. Not other things you write. Just this much you write, then you can understand. Done. This part is also done. Hello.
Yes, sir.
So we are now going to understand uh, some effect like loudness and pitch of the sound, like the way we are getting the sounds. These sounds, some of the sounds have very sharp, you know, they have very sharp sound, right? And some of the sounds we have, those are not so sharp but loud sound, right? So this sound, which one is very sharp sound, like this sound, right? Hello,
Yes,
hello,
sir.
are you listening? So this sound is very sharp, like the sound of cat. How cat is making sound? Meow. This way, right?
Yes, sir.
Hello.
Yes, sir.
So this sound is not so loud, but it's very sharp, right?
Yes,
And
sir.
how the dogs are making sound, that's not very sharp, but it's very loud, right? Isn't it?
Yes,
Yes,
sir.
sir.
Similarly, the male persons, they are making the sound, those are loud, but the normally, what I'm saying normally or generally, but the female person, they are making sound, those are very sharp, right? Not that much loud, but it is sharp. So this sharpness is related to the pitch of sound. We the one which one has more sharp sound, that one we say pitch is more, and the one which one is louder, we understand it. It is loudness is more, right? So this loudness and sharpness depends on the amplitude of the sound and frequency of the sound, right? Yeah.
Yes, sir.
So, can you read it, Monica, from here? A violin?
A violin and a flute may both be played at the same time in an orchestra. Both sounds travel through the same medium, that is, air, and arrive at our ear at the same time. Both sounds travel at the same speed, irrespec- no, irrespective of the source, but the sounds we receive are different. This is due to the different characteristics associated with the sound. Pitch is one of the characteristics.
Yes. So, you understand it, right? Violin,
Yes, sir.
flute, huh? They are having different, sound, right? Isn't it? Hello.
Yes, sir.
So, their difference is coming due to, uh, you know, you see, they are rewriting, but the sounds we receive are different. This is due to the different characteristics associated. So the characteristics is mainly we are dealing with the amplitude and frequency of the sound, right? Now,
Yes, sir.
Mahi, you continue from here. How the brain?
Okay, so the brain interrupts the frequency of an emitted sound is called its pitch. The faster the vibration of the source, the higher is the frequency and the higher is the pitch, as shown in figure 16.7. Thus, a high-pitched sound corresponds to more number of compressions and rarefactions passing a fixed point per unit time. Objects at different sizes and conditions vibrate at different frequencies to produce sound of different pitch.
Okay, so you see here we have two sounds here, right? We have here two sounds. This one is said a low pitch sound, right? And the other one is said high pitch sound. So you also draw this heading you gave, right? Loudness and pitch of sound. Have you given this heading?
Yes, sir.
Okay, so if you're done with the heading, now you draw these two diagrams, and here for this one you give low pitch sound, and for the other one you write high pitch sound. That's it. Low pitched sound and high pitched sound. So high pitch sound, which one has more frequency, right? You see
Yes,
here
sir.
we have more number of cycles every second. That means we have more frequency. Is it clear? Yeah, after drawing these two diagrams, you write this. The higher is the frequency and higher is the pitch. Yes, your drawing and writing is over. Mahi,
Yes, sir.
Monica.
Give me 1 minute.
Yeah, yeah. Please do it. So, Mahi, in your school, which topics you had for your half yearly in physics?
Sir, I think we had sound. No, sir, light and sir, let me check.
You had anything from electricity or thermal physics?
Yes, sir. We did have from electricity,
Okay, so
static
after
electricity.
topic sound, we will go for electricity. Okay.
Sir, I can send you the physics worksheet right now. My exam
With
one.
exam one.
Yes, sir.
Okay, so if you can send me an email, right? If you want to send me an email. Our
Okay, sir.
physics mania email.
Mm.
Done, sir.
Then take your time, no problem. If you want to send, you can also send later. Now, this part, Monica, you read this part, the loudness.
The full one.
Yeah, the right side one, the loudness of softness of sound. This part you read.
Sir, the will I read the whole paragraph?
Yeah, yeah, whole paragraph, please.
The loudness or softness of a sound is determined basically by its amplitude. The amplitude of the sound wave depends upon the force with which an object is made to vibrate. If we strike a table lightly, we hear a soft sound because we produce a sound wave of less energy, amplitude. If we hit the table hard, we hear a loud sound. Can you tell why? Loud sound can travel a larger distance as it is associated with higher energy. A sound wave spreads out from its source. As it moves away from the source, its amplitude as well as its loudness decreases. Figure 16.8 shows the wave shapes of a loud and a soft sound of the same frequency.
Okay, so you draw these two diagrams quickly. Then you give here louder sound, soft sound. Then you write here soft sound has small amplitude and louder sound has larger amplitude. So amplitude you know, right? The displacement, maximum displacement from the rest position, it is called amplitude, right? So here from the rest position the height is small, here the height is more. Is it clear?
Yes, sir.
Hello. Okay, do it please. Let me know once you are done, huh? So Mahi, are you doing?
Sir, I'm done.
Yeah, you are done. So you can leave now. After 10 minutes you join, huh?
Okay, sir.
7:55 you join, huh? Then Monica, how much is left?
Done, sir.
Okay, thank you, huh? Join after 10 minutes.
Okay, sir.
Thank you.